Alright, in this video, what we're going to do is focus on interpreting the arrow graph. Some people still look like they were having problems with this, so we'll go over this today. Now, looking at this, again, the arrow graph is meant to give a lot of information visually. It's not as reliable as it would be just looking at the numbers and processing the numbers, but visually we want to know what is going on. Now, looking at this, we can see that most of the changes, again, this was the exercise one about how well people did on a test before exercise and then how they tried again after exercise, and most people improved, and that's fairly clear. The other thing pretty clear about it is people generally improved but didn't improve a lot. Okay, but overall, we see here that definitely slanting forward, slanting forward, slanting forward. There's only a few that are going back. Some of these lower people went backwards, had a negative change, but the majority actually did improve. Okay. When I go to actually process the numbers, now the first thing you need to do is to be able to actually say, what was the percentage of positive changes and negative changes? I've seen lots of people try to count up the arrows, but then they miss these double up arrows, and they can't tell, is that 3 things or 2 things? It's a little bit darker. Is it a lot darker? Generally, what I do is I go back to my original data. So I look at my original data sheet here. First of all, when I counted up, I had 20 people. So when I do my calculation for the percentage, it's always going to be based on those 20 people. Okay, so I know that going into it, that everything is just going to be, divided by 20, because that's how many people I have. When I look at the positive changes, okay, so that's the sloping to the right. Positive changes, again, I'm not going to count them up here. I'm going to go up at the top and actually look at my change table. So positive numbers 1, 2, 3, 4, 5. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 positive changes in this lot. Okay. So when I go to calculate the percentage, again, it's going to be divided by 20 because that's how many I have in the group. So I'm looking at 15 divided by 20. Now we times by 100, but that just changes it into a percent. So 15 divided by 20 is 0.75 times 100 equals 75%. Okay, so that's our positive changes in this case. Next, we look at the negative changes, so the ones that are sloping to the left. So in negative, it's really hard to write nicely. Negative, again, I could try to count the number of slopes. It looks like 4 going backwards, but just to make sure, I'll come back and I'll just actually add them up. I've got that one, 2, 3, and 4. So I have 4 negative changes. Okay, so people who actually scored worse afterwards. Maybe they were really tired. Now again, it's going to be divided by 20. Whatever that number is got to be divided by 20 because that's how many people I had, 20. So 4 negative changes divided by 20, and then times it by 100 to make it a percent. Okay, 4 divided by 20 is 0.2. Times 100 equals 20%. Okay, and then finally, well, no change. We don't really need to do the calculation. We know there's one person. You could do the calculation. 1 divided by 20 times 100 equals 5%, but we knew that's just the remainder here anyways. Okay, So when we're doing all of these, those are the kind of calculation. That's what the calculation is that you want to be able to do. Okay. So positive change, 15 divided by 20 times 100 equals 75%. Negative changes, 4 divided by 20 times 100 equals 20%. And no change. 1 divided by 20 times 100 equals 5%. Okay, so we'd have that written out nicely. Now, overall, the conclusion that we need to make, and this is the main thing for it, if it's not a 75% change and above, it's not considered statistically significant. Okay, in this case, we were able to get 75%. Okay, we were able to get that in there. That's enough. Okay, to make the call that actually it did have a significant effect. Okay, so then that's the idea that we're going to type in, and that's the comparison we're going to make. So as there was 75% positive change, we can infer, it's nice stats language, that the treatment, and again, I'm trying to put everything into context, where it's not just plain numbers, it's not just a graph, we're trying to put it in context, so that the treatment of doing exercise did have statistically significant effect and improved typing on camera improved people's math scores. Okay. Now, this is what we need for a bare minimum on this. We've made the percentage, we've got the graph, we made the percentage calculation, and then what does this tell us? This is the most important part of this investigation, is the percentage on the arrow graph. If I don't get 75%, either positive or negative, then the treatment had no significant effect. It's not that it didn't have an effect, it's just not statistically significant. This whole idea of, isn't enough that we can measure it and stuff. Okay. Now, this also is a good time, these kind of cases when you're making this call, is that you might make a comment also on people that, because this is a visual graph, where you see something significant visually. In this case, nobody made major changes. If somebody was at the top and then just totally dropped down, yes, that's only 5% change. But overall, this is a pretty dramatic situation. And you might want to comment on that if we're going for a better mark. Okay? But for this one, it was all pretty clear about what happened. Okay? And more of your significant things. Now, I would add